Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI.
Thanks, Jim. Hey, everybody. Thanks again for plugging into the TTI Distribution Download. My name is Steve Brahosky. I'm a Business Development Manager here at TTI. I've been in the electronics industry for over 30 years, 4 of which are here at TTI as an Interconnect Business Development Manager. In this episode, we're welcoming Will Stewart, who is a Senior Manager, Smart Infrastructure and Mobility at HARTING. We're going to be discussing the future of EV charging. So, Will, before we begin, would you mind introducing yourself to the audience and sharing some of your experiences in the industry?
Yes. Hello, Steve. Thank you. I'm very excited to be here. As you said, my name is Will Stewart. I am the Senior Industry Segment Manager for Mobility and Smart Infrastructure. I've been with HARTING for about 8 years now and covering the mobility market for about 4. I set the strategy for how we approach markets, whether that's things like owning the product roadmap, participating in industry organizations, or of course, acting as a subject matter expert to sales. So really, it's my job to understand everything that's going on in the market and knowing how we should approach it. And when it comes to the mobility market, HARTING is a German company with about a 15-year-long history, and it started with our relationship with the German auto manufacturers when they realized that they wanted to start making EV offerings. But if you want to make an EV, obviously it's very important to charge it. So they partnered with HARTING in order to make sure that we could have very rugged and reliable connectors and charging assemblies to charge those EVs, like I mentioned before. And we were very successful doing it, again, going across the German auto manufacturers. And really, we were awarded Volkswagen's 2020 e-mobility supplier of the year. Obviously, very happy with that award, very honored to receive it. But I think it shows that, number one, 2020 was a year of quite difficult supply chain, but also we needed our connectors to be very rugged, very durable. And Volkswagen has thousands of suppliers, and they nominated HARTING as number 1. So very proud of that. Had a lot of success selling to Germany, and naturally, once that became successful, we started selling our products around the world. So we have some experience in this market. We're very proud of our products, and yeah, I'm happy to talk to you today.
Let's go ahead and dive in here and talk about charging interfaces. There's a lot of change. This is a very popular subject in the EV market in terms of the actual interfaces that are used in the mobility industry. Can you discuss the background and the differences for an EV user?
Yeah, of course. So obviously, if you have an electric vehicle, it's pretty important that you are able to connect a plug to your electric vehicle to charge it. One example I would say it's kind of similar to it. It's like charging, let's say, your smartphone, right? Where if you're in the United States, if you go up to any wall outlet, you're going to be able to plug your phone in. But if you go to something like, say, Europe, they have a different wall outlet and you're not going to be able to plug it in. If you have your electric vehicle and you're low on battery, you never want to go up to a charging station and not be able to plug it into your car. So like you mentioned, Steve, there is quite a few interesting things going on with interfaces right now. I think first, just to kind of set the stage, is there are different interfaces that are used throughout the world. So in North America, we use an SAE standard that we call Type 1. That's been used for, I think, over 15 years here in North America. In Europe, it's a different interface. It's standardized by IEC, and it's known throughout the world as Type 2. It's also used in South America. And then in China, there is another interface called Type GBT. So different interfaces that are used around the world, but I think really they have been pretty successful because where you buy the car in North America, you're going to have the right connector available. However, there is one very large exception to that rule. And that is a company called Tesla. And Tesla, they made their own charging interface. So they never used a Type 1 interface. And they used a standard which is now known as the North American Charging Standard. I'll call it NACS from here on out. They had, like I said, their own charging interface, and it worked well for them because they built their own charging stations, right? A lot of other car companies, they just make the cars, and then once you have the electric vehicle, you can charge in anybody's charging station because you know they use the Type 1 interface. Tesla said, we're going to use our own charger, but then we're also going to make our own charging stations and place them all across North America. So if you get low on charge, they got the app, you can look it up, you can go charge your car. Tesla surprised everyone and actually launched their proprietary standard as an industry standard. That's when they called it the NACS charger. And that's when they said, hey, anybody is available to manufacture the charger and anybody is able to use the inlet on their electric vehicle. So this was probably in the second half of 2022. And their goal really was to have everybody start using the NACS charger. Now, nothing really happened with that for about 6 months until in about spring 2023, all the EV OEMs started announcing that they are going to use the NACS inlet starting in 2025. So you have Ford, you have GM, you have Rivian, I mean, even Honda, Toyota, Volkswagen, essentially all North American manufacturers are saying that their North American vehicles will have the NACS inlet in 2025 instead of the Type 1 inlet. So right now, everybody is kind of, I would even say, scrambling to make sure that their offer is ready and to make sure that the infrastructure is ready so that all these cars with NACS inlets can be supported by charging infrastructure when they're available.
So essentially, Tesla created, I'll say, an open standard that then these other manufacturers adopted. Did they adopt it begrudgingly, or did they adopt it because, well, everyone, if they comply with the same standard or interface, it makes life easier for consumers as well as manufacturers ultimately? Is that fair to say?
Yeah, I think that's fair to say. And honestly, I think a big reason why it got adopted was because of the reliability. I mean, Tesla superchargers are known for having a lot of uptime, for kind of always working in the field. And I think that the auto OEMs were thinking they want their customers to have that assurity when they go charge that's related to the Tesla supercharger. And I also think, to your point, Steve, there is benefits to just having one interface being used everywhere. I think it makes it easier on the consumer.
Certainly, as a connector manufacturer, it would, because you can obviously lean on one interface as opposed to having to develop multiple ones for end markets. Is there a role for an adapter to be used by, because there's already products that have been released with Type 1 charger interfaces on them. And so if you need to backward adapt to the NACS interface, I would think an adapter would maybe come into play.
Yeah, that's a really good point. And to draw back on what I said earlier, right? Like with the wall chargers, I mean, if you take your North American wall charger and you go to Europe, there's a simple solution. You get an adapter. So it seems to make sense that we can do something similar with EVs. And we can. These are something that is in development. I do have to note, though, that it is quite a bit different charging a car versus, let's say, charging your phone, and that the car uses a lot more power. And if you take the adapter, right, there's a lot of connections that are made between the wires and the contacts and probably the bus bar inside of it. And if those aren't like very securely made and well manufactured, there could be what the industry calls catastrophic failure, which can be damage to the equipment. It could even be damage to people. So the adapters is, I mean, a great way, and it's going to be a very important part of kind of smoothing over these interface differences. But I would also caution anybody interested in purchasing an adapter to make sure that it's a high quality adapter that is going to be safe. And the way that the industry is doing this, there's an organization called Charin, which has released a statement about adapters. And what they recommend is that every EV OEM, so like Ford or GM, is going to announce which adapters that they've tested with their car and that they know are safe. So if you purchase an adapter, purchase one that your EV OEM recommends. I do not recommend just finding the cheapest one because there's no real manufacturing production safety guarantee.
Yeah, and I can imagine, especially with this market still very much emerging, there's an opportunity for, I'll say, ancillary suppliers to get involved with interfaces, in this case, an adapter that may or may not be recognized by either a rating or a standards authority and or the OEM of the vehicle itself, or in the case of the infrastructure on the charging side of it. So moving into charging, so charging stations can charge either alternating current, and otherwise known as AC, or direct current DC. Can you explain the differences and the impact on both the operators and the EV owners?
Yeah, definitely. So the high level overview is that AC is used for slower charging and DC is used for faster charging. Typically with AC, it can still be broken down into amperages, and we see like 32 amps, 50 amps, and 80 amps. with 32 amps probably taking, let's say, like a full day to fully charge a car, and 80 amps taking maybe like, let's say, 6 hours to 8 hours to fully charge a car. But our electrical grid runs on AC, so it's very easy to install an AC charging station, right? You can just tap into the grid and that power is available. That means that if you want to install an AC charging station, or if you want to put an AC charger in, like, let's say, your garage, typically it doesn't cost as much to set that up because that's the power that's available. However, DC batteries use DC to operate, not AC. So if you're going to charge your electric vehicle and you're going to, let's say, use AC power, there is an intermediary step with something called the onboard charger, which needs to convert the current from AC to DC, and that has limits for how fast it can do it, right? So that's why DC can charge faster, is because you don't need to convert the current, but AC typically is cheaper to install because, again, the general power grid is already using AC.
So yeah, I've read things like the DC charging you just referred to, and I've also seen or read about liquid cooling and megawatt charging, and there's a lot of investment that's being made into charging cars faster so that they can rival the time it takes to fill a gas tank. What technologies, in your opinion, are on the horizon that we should be aware of?
Yeah, absolutely. So that's the big question, right? Is how do we get electric vehicles to charge as quick as a gas station? To have that convenience and have that assurity of that it's everywhere. I mentioned AC can probably charge a car maybe like 6 to 8 hours at high amperages. DC, this is where we get into like 30 minutes to fully charge a car. And again, this is fully charging a car. Oftentimes, you only need to get to the store or get home or things like that. If you want to fully charge the car, maybe 30 minutes, 45. If we want to get down into 5 minutes and 15 minutes, the actual limiting factor is how hot the cable gets. It can like degrade the copper and kind of it just get too hot for operation. So that's where liquid cooling comes in. If we can literally have liquid come in and suck the heat out of the charging assembly, now we can push even more power through the connector. And also the cables can be smaller too in some cases, which makes it easier to use. So liquid cooling is definitely something that's going to be deployed in mass scale, and it may even be the standard for, let's say, charging infrastructure across like highways, things like that.
Okay, because that would require a different kind of infrastructure. Obviously, you're introducing a whole new medium when you talk about liquid cooling, so that's a whole other level of charging.
Yeah. So the power requirements are higher. There is some like safety equipments that are required when you have power that high, but I don't think it's too much of a step to be able to install it. I think the tricky thing is that once you go liquid cooling, you now need a cooling unit. So you need like a compressor and a heat exchanger inside of the charging station, and that's just more parts. More parts require more maintenance. They could potentially have more reliability issues. So I think the installing a liquid cooled station probably isn't too much more of a capital expense than, let's say, just a regular DC charging station, but it's the maintenance of the liquid cooling, which is something that's I think the industry is still trying to figure out.
So, well, can you comment on bidirectional charging? How common is it? What's the level of interest in it, and how would you characterize it?
Yeah, bidirectional charging is a huge trend that has a lot of interest in the community. I know a lot of our customers are asking about bidirectional offerings right now. And essentially, an EV is a big battery, right? You normally use that battery to drive a car, deliver power to a powertrain, but you can use that power for other purposes too. I know like Ford has been advertising like going to a campsite and using your car to power, radio, your phones, lights, things like that. But there's even been use cases for having your car power your house. There's a power outage, or to what's called peak load shaving, essentially reduce the cost of your electricity if you can use it right. So it's really cool applications for EVs. There is some differences to the power cable that need to happen, just some fuses that we have to add for safety, but it's something that's getting a lot of traction, and I think you're going to see a lot of use cases for bidirectional charging here in the next few years.
Okay, switching a little bit from the charging aspect of this emerging market, there's a thing called Buy America. So the Infrastructure Investment and Jobs Act and the creation of the NEVI Fund, the National Electric Vehicle Fund, provides capital to build out charging infrastructure in the United States. And there's some confusion that surrounds Buy America. And I'm hopeful that you can maybe give us some background on this, Will, and where we're at and the impact it's having on this industry.
Yeah, definitely. So I would agree that there is some confusion with this, and I would say that it is because it is extremely confusing. So the government created this NEVI program, right, because they wanted to incentivize decarbonizing our transportation sector and also promoting American manufacturing. Two things that are great that I support fully. And the way that they did this is they created a $5 billion fund which goes to states in order to create fast charging stations along very populated travel corridors, with the intention that a consumer with an EV, if you're traveling on the highway, you know that you're not too far away from a fast charging station if you need it in your electric vehicle. Now, in order to be eligible to receive these funds, there are some things that the manufacturers need to do. And this is the part where it gets confusing, because even though there's one overall idea, each state can kind of implement it differently, and each manufacturer can also take a different approach in order to receive it. The big things that I've seen on my end are, number one is that 55% of the cost of the charging station needs to be sourced from the United States. Number two is significant transformation of the product needs to happen in the United States. You'll notice that that is a pretty subjective qualification. And number three is final assembly has to occur in the United States. Again, these also could change a little bit state by state, but everybody is kind of free to either make 100% of their offer be manufactured in the United States, or be selective about, what's available in America versus what's available overseas. So everybody kind of has a little bit of a different approach and different requirements. Typically at Harting, we work with our customers to try to understand what their strategy is for accessing the funds. We have several levers that we can pull between sourcing cable from the United States. We can use our Elgin, Illinois manufacturing facility, but it's very, frustrating because there's not one size fits all solution. You kind of need to take it on a case by case basis.
Yeah, and I guess with any emerging market, there's obviously some confusion or anxiety that surrounds it. Then when you get laws involved and you're trying to comply with laws and standards, and the manufacturers, the consumers, and everyone plays a part in that. So I can see where it would kind of spawn the kind of frustration or anxiety that you're describing. So charging at home versus charging stations, consumers are considering, whether to purchase an EV, and their charging anxiety that they might have. They're concerned about how long it takes to charge, where they're going to find a charger. Can you explain some of the options consumers have available?
Definitely. So charging anxiety is probably the biggest topic in the EV industry. And I consider that that's really what it's going to take if we really want to get over the hump and have mass adoption of EVs, is people need to be assured that they can charge their vehicle. I also think that everybody can relate to, if you're driving an internal combustion engine, like a gas powered car, driving on the highway, then all of a sudden that gas light pops up and you weren't necessarily expecting it. And perhaps you're running a little bit late to an important event, and now you have to take 5 minutes or 15 minutes to go fill up your car. I think everybody can relate to that. Everybody's done that before. And now if you say that it takes hours to fill up an EV, obviously from the consumer's perspective, that would be, no good at all. But I think people aren't realizing that there's going to be a core difference between gas cars and electric cars. And that is, if you have a garage, every time you leave your garage, you will have a full tank of gas, because you will charge your car in your house overnight. So if you are, let's say, out and about and you're late to an event and you do need to top off your EV, you don't need to do a full charge. You don't need to charge it up all the way. You just need to charge it to get to your event and back home. And also, I really don't think it's going to happen that much. The stats you can find say that 85 to 90% of electric vehicle charging occur inside of the garage. You don't do it out and about. Sure, maybe if you're at let's say a grocery store or something, it might make sense to charge. But most of the time, you will always leave your house with a quote unquote full tank of gas. And today, electric vehicles have 400-mile range, 500-mile range. So as long as you're not driving over 400 miles in one day, you may never need to charge at a charging station. So it's kind of interesting to me that fast charging availability is this big inflection point for mass adoption. While at the same time, it may not be something that's frequently used by a lot of people, but it will give people that assurity. And so I do think it's important to kind of get it out there.
Now, when you put it in that context, I guess I hadn't really thought of it that way, because there's definitely an anxiety and an apprehension because of what we're familiar with a gas combustion engine and the availability of fuel at gas stations. So the way you've just described it in terms of charging at the home and what that allows you to do and the convenience it affords you, what do you do, or how do you envision that being when you have more than one electric vehicle at a household? You need to have more than one charging unless you were to share the charger, which may present its own challenges.
So I do think this will require some electrical upgrades inside of the garage. I do think the power is fully available, but normally you need to do things. If you're going to charge, let's say 2 or 3 vehicles, probably want to have an electrician come in, look at your power box and make sure that there's, let's say, high power outlets that are available, one per car. That's the best way to make sure that they're all being charged at the same time. Now, if you're not using all of the electric vehicles at once, then perhaps you could share a charger between the three of them. But I think it's going to kind of be an interesting few years where we see kind of these at-home chargers be developed, whether it's for one car, whether it's for multiple cars, and also how consumers use it, whether it's, again, upgrading their garage, their electrical infrastructure to be able to charge all of them at once, or using one charger and passing it between the cars.
Cool. Thank you for sharing your thoughts on that. The final topic here is reliability. So there have been, many reports stating that as many as 25% of chargers at a given time may be inaccessible. However, NEVI states that the national target is for uptime of 97%, which is obviously a very ambitious goal. Why has uptime been an issue in the past, and what is going on to make it better in the future?
Yeah, so that was a very surprising stat to me when I learned it. I think a lot of people were surprised by it, how uptime is an issue with like these type 1 chargers. And I mean, there's not really one reason why uptime is at like 80% or 75%, but it's a multitude of reasons. I mean, I think one thing that's difficult is that the company that made the car, the company that made the charging station, and the company that operates the charging station are all three different entities. So if there's something wrong with the communication or something wrong with just kind of the interface in general, sometimes it can be difficult to get to the root of the cause because of that setup. Another issue is that charging assemblies can break if they're dropped. I would strongly suggest that if you are sourcing a charging cable, you find a high quality supplier. I would also offer my company HARTING as a very high quality supplier, if I could drop that in here right now. But that is something to consider, and I think that it should be taken very seriously, the quality and the ruggedness, the durability of the charger. I also think that that's why these auto OEMs are transitioning to the Tesla, the NACS inlet, because while, charging stations in general can have 75% or 80% uptime, the Tesla superchargers are known to have, 95% plus uptime and reliability. And I think, again, it's not necessarily so much to do with the interface, but the fact that Tesla makes the car, Tesla makes the charging station, Tesla operates the charging station so that they can see everything, what goes wrong, fix it, and make sure that everything's communicating appropriately. I mean, I think that the Society of Automotive Engineers, CHARN, everybody's working on the reliability issue. It is getting better, but it's just going to be an iterative process.
Okay, very cool. That's really helpful to understand that a little bit more fully, because there's so many facets to this industry that I think causes people to kind of scratch their head and try to understand it, try to become adopters of it. But when obviously you're going to adopt things that you're more comfortable with than the anxiety that might surround something. So, Will, I really appreciate you sharing your knowledge and your insight on EV charging with us. And I want to thank the listeners for plugging in today and listening to this podcast. I ask that you continue to listen to the TTI Distribution Download wherever you acquire your podcast. And with that, Will, thanks for your time today. And we appreciate the support we're getting from HARTING.
Thanks, Steve. It was a pleasure to be here.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.